Alright, today, thank you. Today we're looking at logarithms. So logarithms and exponentials are related to each other. So if we have an exponential equation, like this, base a to the power of some x is equal to something, then there is an equivalent logarithmic equation that relates to that. So log base a, so that's these two, of y is equal to x. Alright, so x is, if you like, the index that you raise a to the power of to get that number there. Alright, so those two things directly related to each other. So the base number here, the base on your logarithm. So for example, you can use that to say find log to the base 3 of 81. Alright. So if we had log to the base 3 of 81, thank you, is equal to something. So the equivalent exponential equation, base is 3, so it's 3 to the power of something, and that something is x, to give us 81. So we could write 81 as 3 to the power of something. What does 81 to the 3 to the power of? Anyone? 4. So 81 is 3 to the power of 4. So from our exponential equation we could say that x is equal to 4. So our original question here was what's log to the base 3 of 81? Well, log to the base 3 of 81 is 4, because we've got to raise 3 to the power of 4 to get 81.
Do we have to be able to do this in our heads?
For exam 1 you would have to, yes.
So, like, what are they, like, how high do they go? Like, we're not going to have to know what something to the power of, like, 7 is really.
Maybe 2 to the 7, but other than that, no, probably not. And it would be whole numbers, it wouldn't be fractions and that sort of thing.
That is
All right. So, given that there is a relationship between exponential equations and logarithmic equations, it should be no surprise then that they are in fact the inverse of each other.
Well, so do you do that right side before you do the left side? Like all the time? Do I have my lefts and rights?
If you were doing a sum like this, yes you would.
Okay.
So we turn from a log equation to an index equation to help us work that out. All right, inverse. So logs and exponentials are the inverse of each other. So inverse function. The inverse function of
where's that? Oh, we have 4 books. So I wonder, is this a subheading or a new heading?
subheading.
Subheading of blocks.
Okay.
Subheading of blocks.
Okay, thanks.
All right. So, if we have an exponential, fx equals ax, then the inverse of that is the function f minus 1, where we go r positive, there's a restriction on the domain of this. And the inverse is log to the base a of x.
That's bigger. Yeah.
Well, it's the same x as this one, but yes. Alright, so they are inverses of each other.
I just want to become positive.
Okay. So if they are inverses of each other, let's draw the graph. Good question.
Is this an example?
Well, this is just putting this.
Question that I asked.
Nicole asked a question about why it ends up. Alright, so our log, oh, it's not our log, sorry, our fx, which is a to the x, is this. If our these are inverses of each other, we can get inverses by reflecting in the line y equals x, can't we? So if that means that this gets reflected over to there, so for our inverse, which is our log, it's going to intercept there on the x-axis, instead of the asymptote being along here,
Oh, so just like
that asymptote's also going to get reflected across, so the asymptote for log is the y-axis,
So it's kind of like a sideways exponential.
so it's a sideways exponential. Yeah, and so the r plus, you asked where the r plus comes from,
Because it can't be negative.
because of that reflection there. So the domain's only this side, it's not this side.
Yep.
All right, and so this one here is our f minus 1 of x.
I still don't know whether it's bigger. It's the same. Okay, so is it log a and then like pretend that x is a squared thing?
No,
Or is
it's
it
not a square thing. So it's like the A is like, you know how when you have
Is it a little a?
you know when you have like a word like that?
All right.
Oh, really?
That's what A is.
Oh, I got that wrong.
All right, we got it right. Can I rub that off?
Yeah.
Just the top bit, drop the graph.
Rub the whole thing off. Rub it all off. Jen, don't act like you've written this down already. Oh, I have actually. Yeah, that's right.
All right, couple little note.
You're actually doing something for once.
Yeah, for the first time.
Because he come in right on the start.
I think it was pretty well.
Everyone's just like sicky or shit.
All right, a couple of notes. If you have things written like this, log to the base a of a to the power of x is just equal to x. And similarly, a to the power of log to the base a of x is just equal to x as well.
That is my
Is this
favourite
log,
way.
thank you. This log base a and this a to the power of, they kind of cancel each other out. Same here, a to the power of and log base a, they cancel each other out. Just remember that these two things are inverses of each other. All right. Now there is a thing called the natural logarithm. And the natural logarithm is just log to the base e, Euler's number.
Like submarine. Yeah, I remember saying
Log A equals
I know, I feel so bad.
Alright, that's the base of e, which is the natural number. So f of x log to the base e of x is the natural log. And sometimes you see it written. I was about
I didn't say math.
sometimes it's written lnx. So on your calculator in particular, you'll see on your calculator, you'll often see log. Actually, I don't think. And ln. This one here is base 10, and this one here is base e. So you'll often see that. Well, I think on our calculators, I think it just has the little 10 down here anyway.
I don't think it does.
Wait, what's that base part? I don't get that.
So it's what the base is. So often you'll see it written just log with nothing there, that means base 10. Or you'll see ln, that means base of e.
Oh, yeah, it
If
does.
you like.
So it's got an option without it?
It's got an option, and then your calculator's an option with a blank spot here, you can choose whatever.
Yeah.
Yeah. Alright, log laws. Log laws are closely related to the index laws. So let's write down what they are.
Girlfriend converted me free.
Blaming your alcoholism on your girlfriend.
We'll just remind you guys that I'm recording this, like I'm recording every lesson, so just be mindful of what you say that you might not want recorded.
Evidence I have.
Well,
If you did that, it's probably bring out the list of all those main things you said to get.
Alright, directly related to the index laws, if you want to know how these are developed, you can go to your textbook and look at a couple of pages. So the derivations are in the textbook, pages 224 and 225.
Would you suggest doing that, or is that just useless information?
If you're really passionate about
I don't know about.
Look, I took
Alright, you don't need to, you just need to use them. Alright, so the first one is related to the first index law, and that's log to the base a of two things multiplied together.
Wait, is this the first law of law?
First log law is equal to log to the base a of m plus log to the base a of n. Alright, so we'll be using this a fair bit. A lot of the time we'll be going from that to this.
what's that?
That's the thing. The first side.
That's a one with the
That's
dash.
the one with a little dash under it.
What does that mean?
Completely
When
wrong.
is the first one?
The dash is kind of like a
We're so
I'll
interested
go
in
with
that
so
one.
confused.
Would you prefer I used
It's a dot, yeah.
I could look,
And then
Or a bracket.
I could use a little dot if you prefer.
log at baseline, A below, and then M above.
No, M at baseline.
Just
M at baseline.
Suck my toes.
Yeah, where the hell are you over here?
I don't want to be.
The A is a little subscript, Lara, is that?
And then is the N normal?
All right, now if we have a couple of things divided, again, this is something we're going to use a fair bit.
Jeez, without such a big like. It's in the way. There's a little whole line.
Then the one that's underneath is subtraction. Again, we'll use this quite a bit, mostly, a lot of the times going from this to that.
We're going to get some math out.
Now, this next one here, the third log law, we're going to use quite a lot.
We've said we're going to use them quite a lot for every single one, Mr. Senate.
How many are there? Because I've only got 2 more.
5.
Yes!
That's great. That is great.
All right, so this next one,
MP. Oh,
No. Oh, it would have been fine if someone did go aggro.
Are these m's and n's log something to the power of, or are they log something times?
What is that?
log to the base A of some number. I'll do an example, we'll do an example in a minute.
Never knew.
So if we've got something to a power here, what can happen is that this power
This is
can come out the front.
hang on, is that, where's that M?
Hmm?
Is that M kind of on the log? Is it top of the log?
So it would be, an example of that might be something like this. Log to the base 3 of 4 squared would be the same as 2 times log to the base 3 of 4. Something like that.
Now the power has a lot. Oh, that is
No,
really helpful.
and the log that power can come out the front. All right, if you've got a version of this, is if you've got something to if you have something to the -1, a negative, that negative power, that can just come out the front, that negative, so it'll be negative log to the base A of M. And the last one we're going to look at here, 5. The last one, log to the base A of 1 is always equal to 0. And also log to the base A of A is always equal to 1. Because anything to the power of 0 is 1. A to the power of 1 is just A. Alright, let's do a couple of examples. Maybe a few more than a couple. Maybe 5 examples.
I mean, these would just be kind of short, little, easier questions, right? Because you're kind of maybe expected to be able to get your stuff together.
Don't
Make that,
I'm not even on stage.
Stop it.
Alright, can I rub all that off?
yeah.
No, please. Leave the last one.
Hey, if you can hold this again. That's fraction. Can you not? Oh, he gets me to leave, so you have to be on.
This is
much fun was it?
It's not. Express.
Oh, that's such a good time.
Worked up.
Guys,
We just talk about it.
I just want to start be nice. Too low day. What the hell is that? What? I think Isaac did
It always displays a pattern.
Did you say how much?
No, actually not.
And this as well, this one's more.
At least normally I don't, that's on my
All right. So we're asked to express this as a single term, and you notice we've got log to the base of e in each of our terms. So we're going to put all this together. So we're going to use some of the log laws. The first one we're going to use is this one, because we've got two of these, this one here and this one here, that look like this. We've got the number out the front. So what we can do is we can take that number out the front and we can put it up there as a power. And so if we do that, that becomes log to the base e of 3 squared plus log to the base e of 16 minus log to the base e of 6 squared on 5 squared.
How come you don't take the thing?
The negative,
Yeah.
oh you can if you want.
No. Keep going.
No, it's good.
You can, but you'll end up with the same answer,
Oh.
but you don't have to take it. All right. So let's work out what that is. That's log to the base e
3/4 down.
of 9
Clearly not in this context.
plus log to the base e of 16 minus log to the base e of 36 on 25. Now, when you look at the first index law was about when you had things added together. When you have things added together, and I'll come to this one in a minute, what you can do is multiply those numbers, so 9 times 16.
Oh my gosh. That's a big number.
Yeah, it's like over.
That's
144. All right. The second log law was about when you subtracted. Now, when you subtracted log to the base e, what you do is you can divide. So 144 divided by 36 on 25. Now, when you divide by fractions, you
Flip it.
flip it and times it. Very good. So that's the same as 144 times 25 on 36. And when you do that, that's 100. So in a single term, it's log to the base e of 100. That's it, done.
Not bad. Here, put the 100.
Easy as that. That's all.
Simple as that.
Like, it's not easy, but like it's.
So,
How many times
Log
do you write the word
E.
log? 1, 2,
Log base e.
5, 6, 7,
base E is just
12 times.
Just leave it.
15 times.
What? Every time they say log, I think about that log from the Lion King when they see him between the car and they like rip it up and so many tasty bugs come in. That scene plays over and over.
What person has to watch this video? Will they remember this one?
Are you okay, Nick?
Not write that out.
Did you not ruin my whole
Watch
adventure?
him go. Just go to the chiropractor.
Oh, I skipped a step.
Please.
It just looked like there was more steps.
I don't know.
Not to worry.
Alice, you're happy to be here. You're lucky as much as you're not able to pay for your time.
Damn it.
Your
Hate that.
like, please come to my arms, must get overprescribing antibiotics for anyone in class. I know, but she just got to feel straight.
So you got to know.
I feel for it.
Yeah, because she's like, depression.
Shut up, Zeke.
Sorry.
I thought you had tiny titties.
My teddies are just good.
No.
Oh no, they're not as good as I used to.
All right.
No, I have to do a home patient.
No, it's fine. So you will 3 more after this. And then 3 more after this. I didn't know the page.
All right.
No.
So here we've got a log equation. Log to the base 2 of 2x minus 1 equals 4, and we've got to find x. So the way we can do this is we can turn this into an index equation. So as an index equation, it would be 2 to the power of 4
Oh, I like this colour.
equals
Okay.
You do realise we're only 12.
Look at this.
2x minus 1.
Would you suggest doing this in colour?
No, I'm just using a colour to highlight,
Students in New South Wales.
changing from a log equation to an index equation. So the base here is the base there, the answer over here is the power, and that's there.
Wait, does log even matter?
Sorry,
Does log even matter?
just log even matter.
No, like, you know, it's just like you took it out completely.
I'm so confused.
No, I haven't taken the log out, I've changed it from a log equation to an index equation. And to change from a log equation to an index equation, the base that's here becomes the base there. The answer to your log equation is your power,
Oh, is that the?
and the answer to your index equation is what you're taking the log of. So those two are interchangeable.
Is that one of the rules, Mr. Singh?
That is one of the rules, yes. The first one I wrote up, in fact. All right, thank you. 2 to the power of 4 is what? 16, thank you very much. So we've got 16 equals 2x minus 1. Hopefully you know how to solve that equation.
Well, plus 1, so it'll be 17 and then
First you multiply the 2.
17 over 2. That, just leave it like that.
17 over 2, that's it, done.
Or if you want to be...
So by changing, thank you, by changing from a log equation to an index equation, we can solve it more easily. All right, and the same with this next example. I need to rub this out, it's going to take a little bit more space. Right, we all got this? Yes?
This is still solve for x, right?
Still solve for x.
So it can be V.
With a VB. All right, so we've got log to the base e. X minus 1 plus log to the base e of x plus 2 equals log to the base e of 6x minus 8. All right, on the left here we've got 2 terms, on the right just 1. So it'd be good if we could get this, combine that as 1 term, which we can. When we are adding at logs, same base, times. All right, so log to the base e of, and I'm just going to use a square bracket to highlight.
2x. No.
Wait, are we times
No.
We're
X
timesing those 2
squared.
things together.
X squared. Take 2x. Take 2.
Right, so as people have said, x squared take plus x take 2. So what you said? Hope that's what you said.
Yeah.
Log to base e, 6x minus 8. Now what do you notice? You notice you've got 2 things here that are equal to each other. What else do you notice?
So basically, should you just take the x's out?
Yeah, I think you're on the right track
part
there.
of the equations out and just forget about the logs.
You can now
Oh, 'cause
forget
you
about the
cancel out
logs.
the logs.
Because they cancel each other out.
Because
Yeah.
the logs are the same. So the only way you can have the numbers, this answer and this answer being the same, is if this part here is the same. So x squared
So if you divide
plus
by log e,
x minus 2 is 6x minus 8. Take 6x, add 8. X squared minus 5x
Yes, I understand the math noises, right?
plus
Just deal
6.
with it.
Factorise that, what do we get?
Hang on, I'm still writing it. X minus 6
3
x
and-
plus 1. Yeah, what she said.
Minus 6 and plus
Yeah,
8.
minus to minus, minus to
X
plus.
minus 3. X
It'll be
minus
around
X
like that.
minus 2.
Yes.
Has to be minus 2 and minus 3, because we've got to get, when we multiply them, we've got to get a positive number. So, x would be what?
3.
Or?
2.
Or 2. Now, we need to make sure that these answers are valid. What does that mean? That means
To make sure that it's
we can't take the log of a negative number. Alright, so what we need to do is check that both these work. And x equals 2 will work. So, up here, x minus 1, if x is 3 or x is 2, do we get positives? Yes, we do. We'll either get 2 or 1, that's okay. Here we get 5 or 4, that's okay. This one here, 18 minus 8, that's 10, that's okay. 12 minus 8, that's still positive, that's okay. So both of these are okay. So both of these answers,
So if they're positive, they're good.
when we put them back in here, if what we get is a positive number, it's good.
it's positive. They're positive.
And in both of those cases, all of those 3 things are positive. If we've got a negative here, then that particular x value would not be a solution. So let's do an example of where we have to discount one of the solutions.
You know what the volume is.
This is that little, yeah. And then that will go to the front. Because they all have to be, so put a 3 in every one. Oh. write example.
Just write example 3, it doesn't matter.
Just roll with it.
Let's solve it.
3.
Good, you have to start again.
You can rip out the whole struggles because this next page.
Is this a little one?
Yeah, it is short.
Yeah.
No, I used to do books last year because last year I did
Fine, I
this
don't
thing
need
I had
your
half of Yes, no use of it now. Because like the stuff we made just before last year.
All right.
Yeah,
Now when we have things added, we can put them together by
Times it.
timesing. So when we do x minus 1 times x plus 1, what do we get?
X squared. Plus 1.
X times x, x squared, plus x minus 1. So we've got log to the base e of x squared minus 1 is equal to 1. So we only got one log on one side, so we need to change this into an index equation. So the index equation, the base number on our thing is e, so it's going to be e to the power of something. E to the power of whatever's over here. E to the power of 1
Equals x squared. Oh.
equals x squared, take 1. E to the power of 1 is just e. And we want to move this 1 here, we need to
Plus.
plus. So that's e plus 1 equals x squared. And when we get square root it, get rid of the squared, we get that. So we've got two
Except
possibilities.
it can't be a negative because that's the, makes the log negative.
Very good. So,
Right, yeah.
square root of e plus 1, that's okay. Alright, because we've got to be checking here x minus 1. And if you, in your calculator, you find that that's bigger than 1, so that one works out okay. But the negative one, that one there, if you look at that, x minus 1, it's negative square root of e plus 1 minus another 1.
Hang on.
So this here would be a negative, and we can't take, right, that is a negative number.
I'm just going to say can't use negative.
Yeah, I just said it's not.
Is there
It's like
any...
can't have negatives, so.
So we can't take the log of a negative number,
So can you ever?
never take the log of a negative number.
So that x comes out as a negative.
So this particular x is not okay, so we only have, of the two possible solutions, we only have one that's valid.
And you can
Always
know
pick
just from
positive.
seeing the square root that it's not okay? Or do you have to go through looking at?
Well, if you do, get your calculator out. So e 2 points, e plus 1,
Because I'm looking at the board, I'm like,
square root of that. Right, so e plus 1, the square root of e plus 1 is approximately 1.9.
I'm gonna freaking do it.
Okay, so 1.9 minus 1, still a positive number,
Okay.
I'm scared of it.
So that'd be negative 1.9, so negative 1.9, take another one. Negative 2.9, can't take the square root of a negative number, the log of a negative
Why
number.
did you give it back to him? Why wouldn't you just like throw
I
it
don't
out?
know.
Thus the solution is x equals the square root of e plus 1. All right, that'll do us.
Thank you.
Exercise 5D.
Yeah, take that back.